So today is kind of like a bit of a follow-up video from the previous one. It's a plinth foundation detail of an exterior wall again, but we are specifically looking at a facing brick wall, a masonry wall. So we have a facade where the bricks are going to be visible. So of course this is an aesthetical choice, and keep in mind again there are different ways on how we can solve these sort of details. There are different approaches, and it's also really important to understand and to know that those details might not be applicable in any country or region that you might find yourself in. There are always certain requirements but also limitations with all these construction techniques. For instance, particularly with brick constructions, there might be some limitations if you are living in an earthquake-prone country. So always make sure that you research those details really well as well, so they are sort of grounded in a local context, not just from culturally of what is appropriate to use, what kind of materials are common in the place where you find yourself in, but also from a technical and kind of availability sort of standpoint as well. Not in any place you would find these sort of products that are used in certain details and all of that. So that's a very important thing to keep in mind when you're researching how to construct details, but also in your design process, of course. And it's just a reminder that we can do detailing and constructing details in many different ways as well. What I'm really trying to help you is to understand some of those technical drawings, and for you to understand and gain that experience and knowledge of why certain elements are put in those construction details as they are. Not because that's the only or the right way to do it, but really just to understand what's the logic and the sort of motivation behind it. So this is kind of a similar detail that we have seen before with the single stone masonry plinth detail. Again, that bottom part, quite similar. We're not going to look at it, but we'll zoom in into the actual foundation detail up here. One of the key differences here is that we have a facing masonry, so we actually see the individual bricks, and I'm going to pop in a photo, like a reference of how this might look when it's actually built. And we're gonna start investigating into this detail actually from the outside in this time round. Having said that, just one thing I want to stress here again. So we have a similar type of detail where we see a little bit of that exposed concrete on the bottom, and then we have the facade up here. I am talking more about why this is crucial in this kind of detail in the other video, and I'm going to link it up at the top here as well. So if you're curious to know more about it, I'll go into more detail over there. But yeah, let's have a look from the inside to the outside. And again, this bit down here is inside or an interior space again, but once again this one is not insulated, so that means this is a cold interior. If we have no insulation, it means ideally this part should not be heated or in any way climate controlled, because it's just a loss. And let's have a look. These elements are actually the insulation layer, and this is very crucial to understand, so we can make that distinction between a warm interior up here and a cold one. So here we have some sort of a heating system, whatever that might be. The insulation on the floor, of course, gives us thermal conduction. It obviously insulates to the outside. It does not have to be as thick as we would have at an actual exterior wall, because we are connecting to a space which is, even though it is cold climate, it's never going to be exterior climate where it's like extremely cold. So we can allow having slightly less insulation than we would have over here, because here the outside, depending on what climate, what country that you're in, could get really low. It could get freezing, so you want to make sure that you have enough insulation over there. One really important detail, and that's something that you would find in different kinds of construction methods as well, is that all those bricks or whatever sort of material that you have that is actually supporting the loads of your building, this is a load-bearing brick wall on the inside, it needs to rest and stand on something. If it's resting or standing on a layer of insulation, let's assume that insulation is just gonna go through all of here, that's a lot of weight that cannot support all these loads that are coming from there. So on the one hand, you would not have a stable foundation for these load-bearing walls to stand on, and on the other hand, you would squish that entire insulation to the point where it just gets useless. Insulation is not just it's not the thickness per se, it's not the material per se, I must say, but it's also the little air gaps that are within the material. Thinking about, you know, if you have a winter jacket, it's not the wool itself, but it's the air that's sort of trapped in between the fibers and all of it that's actually providing really efficient insulation. And if you don't have any insulation here, let's assume your bricks are just connecting to the concrete. Once again, you are facing a thermal bridge. So that means here on this side, the concrete can get cold, and that kind of, you know, you might have, if it's, let's say, -5 degrees, and then, you know, it gets significantly warmer, yes, but by the time it actually reaches that point, the material can be, I don't know, let's assume 5 degrees Celsius. And if your interior ideally is, let's say, somewhere around 22 degrees Celsius, you have a massive jump of temperature. And that means this is where condensation could happen. There's a thaw point of the humidity in the air, and that can lead to actually water becoming, or water vapor becoming liquid. So a thermal bridge is really, really bad. We don't want that to happen within your construction. So if you erase all these little sketches and stuff, let me get my blue pen back. So this part is super important. Similar to what we've seen in the previous detail, this is probably a standard product or a module that you can buy from the same manufacturer who would make these kinds of bricks as well. So this is a standard type of brick. They might have some smaller ones. You can see this one is kind of bridging that gap, and this one is usually it's a product that you can buy, and the manufacturers would have the specific dimensions and details and whatnot. So this is really good practice, making sure that this insulation layer is continuous all around. Another thing, now when you go outside, what is quite interesting is that we have 2 layers of bricks. As I mentioned before, the interior wall is most likely, it's erasing it again, there we go, is most likely the load-bearing layer. So all your construction weight, everything will be along this layer, transported onto the concrete, and then so on. This is how the load path will kind of flow. So the outside layer, even though it is masonry bricks as well, we can see that over here as well, clay masonry, they are quite heavy, of course. They most likely support their own weight. So as a kind of wall, they support themselves, but they are not carrying any of the weights from your roof, from other building elements, or, you know, from movable loads, people and all of that. All these loads will be carried by the wall on the inside. What we have to make sure then is that we have some sort of anchorage, something that is tying this front layer back to the back layer, because you can see it's quite narrow. And if you have a house, let's say it's a 2-story building, and you have these layers of bricks that are so narrow, that would mean you have to ensure that it's not going to topple over at some point. So you tie them back. And just like that brick on the bottom that we've seen before, those kind of anchorage systems that we see here are usually something that come along with the product that you get from the manufacturer. So the bricks and those ties are usually like they're sold in a system sort of, or they are planned in a certain system. And the way they insert these ties is they screw them into the back wall, into the load-bearing layer. So any kind of loads of the material itself is being tied back to this layer again. And then they rest in the mortar, in the mortar layer between those bricks. Let's zoom in a little bit. You can see it here. So you have mortar in here, which will harden once it's set, and those anchors go back. They're tied in there. What you'll notice here as well as we zoom in, of course, those anchors, they penetrate the insulation layer. This is almost impossible to avoid because obviously you have to go from this layer to the back layer, so you have to go through the insulation somehow. So it does weaken the insulation, and it can lead to problems potentially. Sometimes when you look at buildings, you can see, let's assume we look at the facade of that building, and you can actually see like tiny little spots or like shadows, and you can know where those anchors are, because that's where the insulation is weakened. That's where condensation and temperature drops are happening, and therefore mold or other kind of things can happen. So they appear as like little shadows, but it's really, really hard to avoid that. But one way to sort of tackle this as well is because you have a weakening of the insulation, which will happen, these would happen at like every 10th layer or so, and then obviously in that direction of the construction, in the depth, every couple of meters as well. So you have a significant amount of little holes that penetrate your insulation. So you're going to overcompensate a little bit by just giving it a bit more width, so that you overall as a whole, you can kind of ensure that you meet those insulation requirements. That's one of those things. One thing that we also notice, and it's mentioned over here, there's a ventilated cavity. So again, zooming in a little bit, this is the ventilation cavity. This is quite similar to a timber construction facade. On the one hand, this kind of ventilation ensures that there is some sort of air running through it, meaning that if there's any moisture, humidity or anything accumulating behind those bricks, that it can actually evaporate, it can flow off. Because those bricks are not, and especially the mortar in between, they are not 100% waterproof. So they can soak up a little bit of humidity and then it can seep through. So you can have a little bit of water that's accumulating here. And just the same way as with a timber facade, you want that to flow off. One thing that we have to be that's really important is to have adequate dimension of that cavity. There's a little bit of a tolerance gap that we have to think of, because imagine they are building this, so they have one brick after the other. It's a very usually it's manual labor. You can buy them prefabricated, but there's a certain element of imprecision as well, or what I would call it. You need some tolerance, because all of a sudden one of those bricks could be a little bit leaning into that gap. Or what also happens is that mortar, once you put mortar onto the brick and then you put the other brick on top of it, and then some of that can squish through. So you obviously don't want this to block your entire cavity, so preventing that airflow to happen. And you also don't want this to sort of damage potentially your insulation as well. So this is really important to consider when dimensioning this air ventilation cavity. And then of course any water that's sort of dripping off, it needs to go out somewhere. So here it is really important to make sure that this bit is really sealed off properly, so none of the water can seep into here. Of course, in a timber facade, this kind of ventilation layer and having ensuring that water flows off is much more important, because the timber itself is really vulnerable to water because it could be rotting. So we don't have that issue with the bricks usually, but we have an issue of the insulation potentially getting wet. I've also, in the previous video, I've also talked about what happens if water gets stagnant and those bricks, if they are a bit porous, they soak in some water. What happens when ice is being formed, because ice has more volume than water, so that means if they soak up any moisture and then hold it and it freezes, they can, like little pieces of the brick can burst off, and that obviously weakens the construction. It's aesthetically not very pleasing, but it's also a potential risk for the overall stability and safety of the construction. So we want to avoid that. This brick looks to me like a quite dense, like a really resilient type of brick that's been burned a long time. So I'm pretty sure this must be a product that's, or it has to be approved for exterior facing use, and then I think that should work out all as well. Yeah, but yeah, those are some of the things to think about. One interesting thing as well, if you think about a timber facade versus this kind of masonry facade when it comes to the ventilation gap. In a timber facade, you quite often, if this would be a timber layer, you would look something like this. You have the timber layer here, and then there's a little gap so that the air can flow through. With the masonry, there's a quite elegant little trick that they usually do. So I don't know, maybe after 3 stones, you actually leave out this mortar layer and leave a gap, because if you think about the kind of pattern these stones are making on the facade and so on, you can actually leave out the mortar here, and then the air can go through, and you do that a couple of times. Maybe every 5th stone has one of those gaps, and then the air can flow through. And pay attention next time that you're walking along a brick facade, and you'll probably notice the missing mortar in some of those layers. And then the same would happen on the top, you know, if we have the roof detail up here, the same would happen over here as well. So the air flows through, and then it leaves through these little gaps again as well. So that's an interesting little fact as well, I guess, when you're walking through a city and you watch all of those. Yeah. And once again, just to repeat what we've talked about in the last video about this kind of facing concrete bit and why the bricks are up here and we have that little visual kind of separation. One of the main reasons is that we want to protect this facade from the moisture and the kind of wetness of the soil as much as possible. On the one hand, of course, it's just the water that's in here that could seep up over time through like capillary effects and all of that. And the other thing, of course, is as well when you have rain, it's coming down and it splashes off, and there's just like little droplets that constantly get onto this bit. And so there's always a bit of humidity and wetness in these parts. Usually we talk about having like 15 to 20 centimeters of like a safe zone to protect your facade. It can become mostly an aesthetic sort of problem, but of course over time, if you don't take care of your facade, damage can happen. You can have rotting elements or different kinds of algae and mold growing in these parts if they are constantly wet. So that's not really good. Your materials are not going to age that well. But of course, having that kind of offset of 15 to 20 centimeters here does have an impact on the visual appearance of your building, of your facade. And there's other examples on how to solve that as well. Just thinking about, if you could have like little claddings coming down to sort of and if something happens to them, you can replace them every 5 to 6 years. If that kind of continuity of the brick facade reaching the ground is really important to you, because that's sort of a conceptual and aesthetic statement that you obviously want to make, because it's a really, in architecture, if you think about it, it's really important to discuss and sort of be precise in how your building meets the ground. And it can, yes, of course you can solve that with a technical detail, but there's also some cultural and aesthetic reasons on how you want to treat that moment as well. Other options which we discussed in the previous video as well, let's assume the ground was here, then you would have to think about having some sort of a metal protective element. So if you have water here, it does protect it as well. There's certain coatings that you can do, like almost like what we have on the bottom here, probably like that bitumen, or there could be a bitumen layer here. There could be some sort of a coating, a paint that you put on to additionally protect those bricks as well. You would potentially visually see that as well, because they would have a different surface quality. They could be more shiny, whereas these ones are matte. So this is really hard to avoid. But yeah, these are considerations and sort of trade-offs and compromises that you have to make when designing details, and you have to negotiate with yourself. And of course you want to have a certain aesthetic or visual goal, something that you want to achieve, but at the same time it should be functional and technically feasible as well. So that's the difficulty of constructing details. Great, awesome. I hope the video was helpful in understanding the motivation and some of the logic behind these technical drawings, and understanding why certain things are presented in the way as they are. If you have any comments or suggestions, particularly if there are certain details or types of constructions that you're particularly interested in learning more, that you may be struggling with, let me know in the comments below. Hopefully I can address that in some of the future videos. Thank you very much.